Welcome to Elemental Science Magazine, where science meets the planet. Today, we're diving into a force reshaping our weather, one that lies hidden in plain sight: our oceans. The oceans, vast, blue, seemingly endless, are acting as the Earth's thermal battery. They've absorbed roughly 90% of the excess heat trapped by greenhouse gases over the last few decades. In fact, 2023 to 2024 marked the warmest ocean conditions ever recorded, a continuation of a trend that began in the mid-20th century. But this heat doesn't just stay put. Warmer oceans evaporate more water and redistribute heat through currents and air circulation. That means ocean warming has become one of the most powerful forces driving changes in global weather. Modern ocean temperature records began around 1955, and by the late 20th century, scientists had confirmed the oceans were steadily warming. But the idea isn't new. Back in 1938, Guy Callendar noticed that global temperatures were rising, a hint of what would later become the climate crisis. It wasn't until the 2000s, with floating sensor arrays like Argo, that we truly grasped how much heat the oceans were storing. Let's talk about hurricanes, nature's most powerful storms. These tropical cyclones are fed by warm ocean water. The hotter the sea surface, the more energy is available for storms to grow. Since the 1990s, 8 of the 10 most active hurricane seasons in the Atlantic occurred in this warmer ocean phase. But the key change isn't just the number of storms, it's their intensity. We're now seeing more Category 4 and 5 hurricanes, and more frequent rapid intensification, when storms suddenly explode in strength over warm waters. Hurricane Ida in 2021 is a textbook case, gaining tremendous power in just hours as it passed over the hot Gulf of Mexico. Warm oceans also mean more moisture in the atmosphere, so hurricanes dump more rain. Events like Hurricane Harvey in 2017 showed how this leads to devastating flooding. And with evidence that some storms are moving slower, the flooding gets worse. Even if the total number of landfalling storms hasn't increased sharply, the cost and danger have, because today's storms are stronger, wetter, and more destructive. Here's something that might sound contradictory. Warmer oceans are driving both heavier rains and deeper droughts. How? Because a warmer atmosphere holds more moisture, increasing the fuel for downpours. But ocean heating also affects wind patterns and storm tracks, sometimes pushing rain away from regions that depend on it, worsening droughts. In fact, the water cycle itself is intensifying. Wet places get wetter, dry places get drier. A vivid example is the marine heatwave nicknamed the Blob in the Northeast Pacific between 2013 and 2016. That ocean hotspot was linked to a high-pressure ridge that blocked rain from reaching California, extending a brutal drought. At the same time, warm oceans can supercharge atmospheric moisture, leading to heat waves inland and record-breaking floods, like the 2022 floods in Pakistan, intensified by warm waters in the Arabian Sea. Now let's shift to the Great Monsoons, critical lifelines for agriculture in Asia, Africa, and the Americas. As oceans warm, they pump more moisture into the air. This leads to an overall increase in monsoon rainfall, up to 2.4% more per 1 degree Celsius of global warming. But not all monsoons are created equal. For example, South Asia's monsoon is growing wetter, with more extreme rain events, partly due to Indian Ocean warming. On the flip side, North America's monsoon, vital for the southwestern U.S., may weaken, leading to water stress and agriculture losses. Air pollution complicates the picture. During the mid-20th century, aerosol emissions muted monsoon rainfall by blocking sunlight. As pollution controls improved, the rains came back, but now with more force. The future: more rain in total, but delivered in shorter bursts, with longer dry gaps in between. A dangerous combo for farming and flood risk. Ocean warming even reaches the poles and the skies above. The Arctic is warming over twice as fast as the rest of the planet, partly due to warming ocean waters and melting ice. This Arctic amplification is reshaping the jet stream, the high-altitude current that steers weather. Normally, the jet stream is tight and fast, fueled by the temperature contrast between the cold poles and warmer tropics. But with that contrast weakening, the jet stream is becoming wavier and slower. What does that mean? Weather systems can get stuck. Think prolonged heat waves, like the Siberian Inferno in 2020, or frigid cold blasts, like the Texas freeze in 2021 when the polar vortex went rogue and Arctic air plunged southward. Some scientists see a clear link between Arctic warming and these persistent extremes. Others are cautious, noting natural variability. But either way, the evidence is growing that the poles are pulling strings on mid-latitude weather, with oceans playing a major role. Finally, let's zoom out to the Atlantic Meridional Overturning Circulation, or AMOC, the system of currents that helps regulate climate across the northern hemisphere. It's powered in part by temperature and salinity gradients in the ocean, but melting ice and warming seas could slow it down. If the AMOC weakens significantly, weather patterns could shift dramatically, drying out parts of Europe, shifting tropical rain belts, and even changing monsoons. While a full collapse isn't likely before 2100, this system is under watch. Because when it moves, the entire planet feels it. To wrap up, ocean warming isn't just a background detail in climate change. It's one of the central engines driving global weather disruption. It amplifies hurricanes, it intensifies floods and droughts, it alters monsoon behavior, and it reshapes the jet stream, making weather patterns more extreme and unpredictable. What started as silent heating in the deep blue is now reshaping the world above it, and we're all in the splash zone. The science is clear. Warming oceans are both an early warning system and a driver of climate change. Understanding them is key to predicting and preparing for what's next. Thank you for watching Elemental Science Magazine. If you found this episode insightful, consider sharing it, subscribing, and leaving a review. Until next time, stay curious, stay informed.